I don't have a mic. How do I do this? Like with this one?
The green.
The green one. Ah, yeah. Okay. So yeah, the project that I tried to present now is some project where I thought maybe it's good to tell some background first, like about Nina and also myself and how it came actually to us doing this project. So it kind of starts first like with a little history of what we did in the past, but then it progresses to the actual project. So okay, it actually started with like her going for some political sciences and studies and to understand the world better, and I was thinking in order to understand the world I need to figure out what would be best and learn some business stuff and some computer science, and thought this is what I need to understand the world, and like wanted to go for a corporate career, and figured out there's lots of things that I didn't imagine that they would be like they are, and so I kind of made like a very went and tried to change some things and went into some Occupy, which I was never like into so much into activism or any politics at all. But like then when I was like 20 something, I did this because I thought maybe that's the way to change some things that I didn't like so much. But it didn't turn out to be like the best way how I imagined it again. And Nina figured out that like a lot of this, when she tried to go for politics and study this, that there's a lot of things that like are more about power, and she felt it was not so much about content. So she went and explored a bit of some more basic interactions with other people, and yeah, we both found like some inspiration in this, and now we thought, okay, how can we bring this how can we bring this or how can she bring this to a wider audience? And me figuring out that maybe these approaches that I try to do, like with trying out to be in the Pirate Party and going to Occupy, where it felt like, okay, it's like a protest, but it's not so much about changing stuff. So it's like a bit powerless, like we don't do anything. It's like more others would do it for us. So then we learned about that there's this thing called startups, which I was never aware that this exists, and we thought this would be maybe the solution. So we both had like an excursion into this world of startups. Like she's tried a little startup, and I tried to get more knowledge about this. How can I maybe create something to bring like a solution through business or whatever it would be, and like ventured into this and founded like a little student club for entrepreneurship. But it soon felt like it's again not how we can do things. So then I figured, okay, maybe we have to bootstrap to really do the nice experience that we imagined we have to do this like ourselves, but then we have to learn the skills first. And that's how I actually started the first time in my life then to really go and learn programming myself. Like in the studies, I kind of learned about it, but I never really did it. And also Nina came through this, like maybe she could make an app, but programs are expensive, so maybe she could learn it herself. And so yeah, that's how our open source started. Like I had like some little bit of knowledge about Java and she about Ruby, and we found then later JavaScript would be nice to make apps and bring it maybe in the browser to people. And so this was like 2013. So kind of that was like a long history into one slide. And we started in 2013 when we both came to Berlin. How can we find like like-minded people? Because this was very hard for us in the past. Like we were surrounded by people who didn't share like our mindset or couldn't really understand what we try to do. And it was also hard for us to express this really. So we thought maybe we can start just a meetup. And then we play around with like the description of the meetup to figure out maybe we can find some people who have similar thoughts or similar ideas. And that's like how we started this meetup like in 2014 early. That was basically the idea. That is basically the same that we want to still do with the RefugeesWork, but this leads later to this. We wanted to figure out how we can find people who would be up for who maybe have like a bit of an activistic side, but also who would be entrepreneurial and who hopefully would be coders or some kind of people who would do things. And we could brainstorm together about how can we change certain things that we maybe don't feel they should be like they are, all being kind of fuzzy, but still, whenever we went into like this traditional path, it was very hard for us to really connect to other people because somehow their thinking was slightly different. And this was like an environment for us to learn and help others to also learn. And with the goal that we maybe are either a bunch of freelancers that connect, or maybe we build our apps, or we bootstrap some maybe not startups, but like apps or something that could make money and make us independent. But also in a nice way where we share this more, and maybe if we have multiple apps or something that we connect via API, or we have like lots of thoughts still about it, and it's not clear, but that we just do it different. I don't know. So from there, the first thing that we did then was like a little programming school. Like we had like this inspiration, like basically two things. Like one was that in the UK in 2014, like late 2014, like the whole country started to teach like programming to every kid, like starting from primary school on. And in Germany, I'm not aware of anything that would kind of have similar ideas. So we thought maybe we can use this opportunity and start this here. Maybe this will become a trend later. And also we were like inspired by one little, coding school, or I don't know if it would be even called a coding school, but it's called Cyber Wizard Institute. That's like a project in Oakland. And that was very inspirational for us. We thought maybe we can try to make something similar here. And then we went and taught some children, and we had like some little events where we made tried to visualize some algorithms with some things that are not computers, like this, like visible on this picture there. Show some algorithm with some stuff, like some games. And also, of course, continue to learn in our meetup and teach what we kind of slowly discover for ourselves also to others who are coming, and also learning from them when they came and showed us inspirational things. And this was like the first thing. We hope that through this we find like a lot of people who might also be then, because we're teaching this, also in this mindset of, hey, we can maybe do stuff ourselves and we don't need to go for a normal job. Maybe we can try to be self-employed or freelancer or do our own little apps. And we were inspired by people who came to our meetup and showed exactly this. And they came from all kinds of other backgrounds. But then also in 2015, there was like this refugee crisis. And then a lot of refugees came to Germany. I think in total like over 1 million. And that's all in a very short period of time. So we thought maybe we can do another app, and this is where we then started RefugeesWork. So we thought with the kids, they might need some time until they would consider to be self-employed or doing stuff on their own, and there's also the parents and everything. It was a very nice thing, but we thought maybe with the refugees, we can help them to teach them something, or if they already know it, then maybe they can join us. And given that we know that most companies, and as it turns out that is like true, they want people to speak like German before they can really start working. I mean, that's like mostly the case, but with the programming, I made the experience that if you speak English, then that's fine, and if you know programming, so you don't have to speak German necessarily. So we thought if we teach them this, or they know it already, we can join forces, and because they come here and don't have anything, they would also be motivated, and we can do it together. So we had like a lot of these job postings, like we tried to share this, and we got like hundreds of offers. Many of them were kind of IT related at least. And we also got like, I think up to, I don't know, around 400 refugees signed up for the app. This like from our admin interface. So yeah, something like users and also leads, how they post projects. But then again, they didn't apply so much as we thought they, we had like actually a lot of postings for jobs or little projects, and also a lot of signups from refugees, but somehow they didn't apply as often as we were hoping for. And then we figured out they're actually pretty young. So like many didn't finish their school, or if they didn't, then they didn't finish their studies. So they didn't, not a lot of time left, okay, I see. So we thought, okay, maybe we should help them, teach them first some skills so that they can apply. So we thought, okay, we have already this experience from this school, so let's make an online platform. So we actually started to have like a little project where we built like an online platform to learn some programming, and we're able to do this like in an open source way. So we did the wizardamigos.com page and took all this, what we could use open source. I mean, we just had to rebrand it because like the logo and everything was damned, but the content we could reuse. And now we have some refugees who learn this online, because in that project, like this ESOVA project, we had like 1,500 learners who went through the program in a very short time. We could never do this teaching face-to-face. And now we have this here, and we hope with this we can help more refugees to actually apply for these things. Yeah, that was kind of it. Maybe one last thing for the next steps, what we also plan is to help them with the self-employment. So we opened a limited for us already, and we would like to maybe also do this in Germany, but there's the problem, you have to have a notary service to open a company, so it's hard to do this just via API online. And to help them like set up all these things. And for this we also go to like next month to Taiwan, which is like a bit off, but they have like this Gov0 thing where they try to open a lot of government data, and we hope they can inspire us too. So there's also the Open Knowledge Foundation, they also open source a lot of data, and maybe we can use this to, like, because like the bureaucracy feels like a big hurdle to do this. Like the skills and programming is one thing, but it's still the self-employment thing is a lot of bureaucracy too, especially in Germany. So yeah, that was kind of it, I think. Thanks.
Hey, thank you very much. I don't think we got any questions. If you do have questions, please tweet them at that_project. In the meantime, while Carissa's getting set up, I do have a question actually. Yes. Are you looking for contributions or help in any way, like programming?
Yes, actually, I don't know. So there's maybe here we have like this waffle board where we organize our tasks, and we also have a chat, like a Gitter chat, and we have actually a lot of things that we would need help with. I don't know. I mean, a lot of things. Yeah. So if somebody feels like doing something, or please feel free to contact us.
People find you on the internet and can
yes
to this awesome project. Cool. All right. So this will be easy. I'm going to unmute.
Yeah.
Oh, okay. Cool. This is a really cool thing that's happening tomorrow, called Netzpolitik, that I'm going to be going to. There's a party at the end of the day. Just thought I'd get that out of the way. Okay, so my name is Carissa. Okay, so today I'm here to talk about DAT, and I'm trying to close this bookmark thing, but I don't.
Command Shift B.
Huh? Command Shift B? Ah, okay, that's fine. So, all right. So I'm glad to be in Berlin. I've been here 3 times this summer. I've been traveling around Europe, and it's been really exciting.
This is my last time here. I'm here till next Thursday. And I wanted to just talk a little bit about that, just an overview. I'm not getting into technical stuff, but we're going to be talking afterwards about like technical stuff or like how to get involved more during the break. So if you want to talk more, come up to us. So DAT is a nonprofit, and we're funded by the Alfred P. Sloan Foundation and the Knight Foundation. We're also open source, so everything we do from day one is put on to GitHub, which is really exciting because it lets us contribute to a lot of open source projects and a lot of small modules. And one of the big questions that we were really trying to tackle is why published research cannot be replicated. So this has been a problem for a really long time, but it has become more and more of a problem as data and digital data has become integrated into scientific studies. And it's becoming such a big problem that almost half of psychology studies couldn't be reproduced last year. And there's a lot of people that want to solve this problem. But we have to ask ourselves before we start solving the problem why this is the case. And so we were looking a lot at data is lost. So why does the data get lost? So when people ask, hey, I really want to get your data so I can reproduce your study. And the data was like done 3 years ago by some grad student who had it in their network drive on their computer, and then they, lost it, or they lost their account or something like that. So the data is just gone, a lot of the cases. The second biggest case, I think, is the data is really large. So even if I wanted to give it to you, it would be like, what part of the data do you want? And like, how do I even transport it to you? And do I want to spend the time sending you 300 terabytes? Probably not. Another thing is the data is private. So a lot of scientists or people doing research, they want to keep their data close to home. They're very worried about someone taking their data and doing a study before them. So a lot of people don't want to share their data until they've actually published their paper or published their analysis. So doing it in the open is a little bit scary for them. And then the last thing is data is expensive. So if you wanted to host data for it to be reproduced forever, just think about how expensive that would be and who's paying for that. So if someone downloads from me, I'm paying for the bandwidth. I don't really have an incentive to keep my data on the web just so someone can reproduce my data set. So oftentimes the data, no one knows who's paying for the data storage. So GitHub, right? GitHub's supposed to solve all of our problems. So a lot of people say, okay, we'll just put the data on GitHub. Unfortunately, GitHub doesn't solve a lot of the problems. One of the biggest problems I've seen with scientists and people trying to use Git for collaborating on data and publishing data is this command and this kind of nastiness that happens when you try to merge data sets or push or collaborate. So scientists often end up using shared network drives. So how do data scientists collaborate? They use shared network drives, and they often use Dropbox. So we started looking at this, and the worst part is people often use email. So I still see people emailing around docx files and this sort of thing. The thing is, scientists don't want, people who are domain experts, they don't want to be focused on using like a complicated tool. They rather get the thing done that they're looking to get done. So if they're going to use Dropbox or email, if that's the thing they've always been using, they're just going to keep using that, and they don't really have an incentive to publish open data on something like GitHub. So it's still, even though GitHub has been around for a long time and people want to use it, the large majority of the community still does not want to use it. And one of the big problems about Dropbox, it is not reproducible. So if you actually wanted to look at back in time or what you did on your Dropbox, it's really confusing. I don't know if you've ever tried to go back in time on your Dropbox and look at the history, but it's very confusing. The versioning is just not there like there is in Git. The redundancy, you only have one Dropbox. Like if you lose your user account, there's not an easy way that you can just automatically export it to a bunch of different computers. So you're kind of dependent on Dropbox. You don't have this forkable thing that Git has that's really nice, so you can have copies of your data in different places that are owned by different people, and they can change that data and then submit patches back. And it's not open, it's a private company. At the end of the day, we really want to use something that's open from beginning to end, that's open source. So we've been trying to solve this problem with all these things in mind. And also we want it to be free, not just like free as in money, but also free as in like Libre. So how can we help scientists and researchers and people who really want to study these big problems and don't want to focus on developing? This is where DAT comes in. So one of the big things that we're trying to solve is how can we make this infrastructure that is commonly used, where you have a server in the middle and a lot of different computers that access the data, how can you make this more efficient, and how can you make it more redundant, and how can you make it more open? And one of the biggest things that we were thinking was the peer-to-peer model. How many of you are familiar with peer-to-peer or BitTorrent stuff? So we basically were like, why don't we just use something like BitTorrent for this? So peer-to-peer is really nice for open data, actually, because when you change the data or want to update the data, you can share it with a bunch of different people, and everyone has a copy of the entire history of the data set. So if one person goes offline, you can still get an access to that data from someone else. So it's really nice to keep data open. Whereas in this model, if you have one, like a library or a non-NGO or government that has the data, if it's slow, or if it has an outage, like data.gov had an outage last year, or if it gets DDoSed or something like this, the data is just unavailable. In this model, even if the data is available, you can get it from someone else. So these were kind of the big design choices. So what we have in mind is if we have a bunch of different organizations that are sharing and publishing open data, universities, newspapers, nonprofits, NGOs, governments, and they are all sharing data with each other. Everybody's data will be faster to download. It'll stay open longer, more likely to be available at any given time, and everyone will have a copy. So we have a few different ways to interact with DAT. The first is a command line tool. The second is a desktop application, which is still being developed. And if you want to talk more about this, we have a developer who is working on it, Julian, back here. You can talk to him at the break. And then we have a web app where you can share with other people who don't have either the desktop app or the command line tool downloaded. So I'm going to give you a few demos, and then we'll go to a break. So, let me see here. Okay. Okay. So what I've created here is a DAT on dat.land. So this is a website you can go to called dat.land that has basically a list of the files that I have in my DAT. So a DAT is just a list of files, just some like Git, also has folders and that sort of thing. And I can take this hash. There's like a link here at the top. I can take this link, or I can hit open a desktop app, and I can open it on my computer and start downloading it. So if you see this network just bumped to 1, and this one also bumped to 1. So what happened is that my web browser is actually connecting directly to the desktop app, and they're updating with each other. I can also go to the command line tool. So if I want to download this hash, so this is like a unique hash basically that represents the data. We're going to be soon making user accounts and stuff, so you don't have to like copy and paste this hash. But a hash is essentially this string of characters that uniquely identifies the data forever. And you someone can continuously write to, you can keep writing to the data and add to the history of the data set, just like with Git or Dropbox. So what happened here is that it connected and it is downloading the items directly from the desktop application that I'm running also on my machine and from here. So this is great because now I can give this link to someone and they don't have to have DAT at all. I can host this on my server. Say if I'm a developer, I can host this on my server, or I can have it on my desktop app, and I can give this link to someone and they can go and download my data. And what happens is it's not going through any central servers whatsoever. It's going directly from my terminal or my server to this client, to this website. So someone gets to download the data from everybody who's connected, and it'll be a lot faster that way. One of the cool things about DAT that we spent a lot of time on was making sure that you can preview data sets without downloading the entire data set. So if a data set is like 700 terabytes, for example, you don't have to download all 600 or 700 terabytes just to view the columns in a CSV, right? So this is a very common problem where you have a CSV that's like really big and you just want to see a little bit of it. So if you put something on GitHub, this is only 3 megabytes, if you look. This is only 3 megabytes, but GitHub still is not able to preview the file. So what I did is I uploaded this to DAT, and if I click here on this, I'm able to see the first 10 rows of the file, because what we're doing is we're able to use something similar to BitTorrent, where you grab just a little bit of the data at a time. You can ask, I only want the first 10 rows of the data set, and then I could say, I want the next 10 rows. So this is a nice, really nice property of the peer-to-peer network that we're leveraging. So it makes it really nice for developers, but also for just regular people who want to preview data sets and not have to download the entire thing. What am I doing at time? So another one of the really cool use cases that I've been excited about is the California Civic Data Coalition. I live in California, so I heard about them. And they have an open source archive of the daily downloads from the money and state politics in California. So every day, Sacramento government publishes a zip file, a 700 megabyte zip file of the data dump of the SQL database that is all the money that has been put into politics in California. Every day it's different. And they just delete the old one at midnight and throw the next one up every day. So this project is literally an external project funded also by Knight that makes it so you can get access to these older ones. So what they do is every day they download the zip, and then they load it into a database, and you can see all the past ones. So if you see, look, this one's 762, this one's 758, this one's 757. So every day they're uploading these data sets, and it goes back. They just started the project this year, July 27th.
So this project is to transporting of the money to the public?
Yeah, it's about how people give money to politicians.
But how the public can see a file like that in a graph? And
Right.
just a raw matter for regular citizens.
True. Yeah, that's
It's missing someone to take the. Okay.
Yeah, exactly.
It exists or no? But
Simplified files, reshaped. I think that they're working on this right now. Seems like this project is working on this right now. Yeah, so this is a fairly new project. And so I imagine, yeah, they would love to do this. So one of the things that DAT would be great at is something like this project, which I'm working on right now. Basically, with DAT, all I would do is download this, and instead of having 700 megabytes every time, if you wanted to get the new files or the new changes, you only have to download 1 megabyte. You only have to download the new changes. So it's like Git, because you already downloaded the old stuff, so when you git pull, you only download the new changes, right? So DAT would be similar. and you could like go back in time and see one of them and see a diff between the two. So these are the kinds of things that we're working on next. This is one of the cooler demos that I'm excited about. So we have one Twitter question. What's the Twitter question?
Yes, we have one question from Moritz. Do you collaborate with journals that require open data?
Do we collaborate?
With journals that require open data.
With journals.
Yes.
That's one of the things we're actually working on right now. So hopefully within the next year or so, we're looking to collaborate with a few journals, or hopefully at least make it easier for people to relate a journal with a data repository. Are you aware of data.world and their efforts? Yes, actually I heard about DataWorld like last week or 2 weeks ago. Seems like a pretty great project. I think that one of the things that I would say about it is that it seemed to, let me see, data.world. It was like very user focused, so it's like you have a user account or something like this and you post data, which we're kind of working on, but we were working first on the data transport mechanisms and the storage and the decentralized properties first. So we're really excited about having user accounts, which is something we're working on right now. But we were focusing first on making sure that the tool is usable for historical data sets and it works for very large data sets, which was kind of our priority. Can I share stuff via DAT without uploading it to central cloud storage if I want to? Yes, you can. So I can share something by simply going to the command line tool. So I can say DAT desktop example, and right now it's sharing the DAT, so it added 159 items. And I can take this link and give it to someone else. Here. So pretend I'm someone else. And these will connect directly to each other. And so this isn't going through any cloud servers whatsoever. The only thing that gets exchanged is my IP address, but it's just to each other, so they both know how to transfer data to each other. Any more questions? I think we're good. So if you want to talk more, we'll be in the back corner, and we're going to talk more a little bit about if you want to build something with that. We're going to have a little workshop on using the JavaScript API or the command line API. So come by and let's talk more.
One more, can I use it to host like a static HTML file and then use it like to host basically an app?
Yeah. There's someone working on that. It's called Beaker browser.
Oh, okay.
And it's used, so if you want to check this out, this uses DAT and a bunch of other stuff too. It uses IPFS, I think, as well. But it's it doesn't have a good screenshot. But yeah, if you go to Beaker browser /Beaker.
There's a link to the website, I think.
Oh, okay, cool. Okay, here we go. So then you can share and create and host websites directly from your.
Once there's user accounts, would it also be possible to kind of sign into another person's app?
We should talk about that later. That's like a lot of people are working on that, and it would be really cool. He was asking if it would be possible to sign into one of these websites. But thank you very much. We'll have a 20-minute break, and then talk more after. So again, if you have more questions, you can tweet at dat_project. Albert is going to talk about academic writing with Pandoc, the universal document converter.
Right. Thank you. So Pandoc's a project I really like, so I figured I I should give a brief presentation. There are actually far more people here than I expected, so I'm a little bit nervous. Just to give you a quick overview of what Pandoc actually does, here are the basic features. It converts markup. So you've got one kind of markup like Markdown or HTML, whatever, and you can convert it into another kind of markup, which sounds simple, but it's actually really, really useful. It also includes a very basic, or well, not so basic, actually, templating engine. It is very, very extensible, as I'll show you later, and it was created by John McFarlane 10 years ago, and I count this as a feature because John McFarlane is a professor in Berkeley, and he's really interested in writing his papers with something easy, and he chose Markdown, and Pandoc kind of grew around it, and he's still supporting it, and that makes it even better in my opinion. And it's written in Haskell. Your opinion may differ if that's actually a feature. I really like it. For me, it was my first Haskell project. So here is the full list of format it supports. As you can see, the slide is quite full, overfull. It supports Markdown in 6 different dialects. All kinds of lightweight markup languages like restructured text, which is Python mostly, Textile, some wiki stuff, Emacs org mode, which is the stuff I'm usually using and working on. And it can convert to all of these and even more, like it converts to ASCII-Dirk, to LaTeX Beamer, to Reveal.js, which is what you see right here. Reveal.js is this presentation format, and it's really easy to choose something different. So this is an org file, and if I convert it to PDF, it's still an okay looking presentation, I think. Same slide. All right. So why is Pandoc actually useful to academics? Well, obviously because it makes writing really easy. You don't have to think that much about how you style something, how it looks. I mean, LaTeX is a very popular choice in academics, but it's also really, really complicated. And Pandoc takes a lot of that pain away. It also makes, like, it's really good at converting things, like mathematical formulae. They can be converted to actual Word formula, to MathML. Like this really looks like it was written in the output format if you convert it, which is quite amazing. It also has citation support, which is a must-have for something used in academia, and the citation support actually allows people to use many different input formats as well. So BibTeX format works, EndNote, stuff Zotero spits out. And the creation of different kind of documents from the same input document is also something quite useful. So if you, for example, if you go on GitHub and just type in Pandoc, you'll find a few projects by professors or other people who give talks where they just have one document and convert this thing to slides, to handouts, to, I think they even do the final tests using Pandoc sometimes. And the greatest thing about Pandoc, in my opinion, is that it just combines flexibility with simplicity. So even though it's really easy to use, you can do a lot of stuff with it. So here's a little bit some points about how it can be extended. Well, first of all, you can write custom templates. So if you want to convert to HTML, there's a default template. So you can have your plain looking HTML page, but you can also put in your own template, and it will spit out a really nice page as you designed it, and fills in the body, some metadata, everything it knows from the document. One other really great feature is that it allows you to run filters on the document. So Pandoc works in a way that it parses all input formats into one unified data structure, which is kind of cool, because then you can work on that unified data structure. This allows you to export the data structure as JSON. Pandoc does that. And you can use any other tool to read that JSON and to act on it in whatever way you like, whether it's functional, or you can parse it into objects and then act on those objects. It's really powerful and useful. Also, there are, like, since it's so easy, many people already did a lot of stuff with it. So if you look around, you'll find many filters available in many different languages. So PHP has something to read in the Pandoc format. Of course, JavaScript, Python. I don't know everything, but there are a lot of that stuff. So why does it matter to science in a broader sense? It's also used in a lot of science software. So, of course, you can view your editor as a kind of science software, and there's certainly a Pandoc plugin for your editor. There's also RStudio, which is an integrated development environment for R, the programming language. It's using Pandoc in the background. There's Jupyter, which is a browser-based notebook, originally for Python, but now also usable for some languages like Julia and Haskell. And there's a commercial tool, Authoreo, which is a small startup in New York, I think. And unfortunately, not open source, but I think still quite usable and useful, because it has the idea to bring forward collaborative writing. And so Pandoc is in use there as well. And yeah, just to give you a brief outlook, what's going to happen next with Pandoc. At least I think I would like to add document internal references. That's a feature that's actually missing right now, so something like ref in LaTeX isn't possible. I'd like to push the execution of code snippets via filters, so to build something that makes it easier to have something that describes an image in some kind of way, and to compile that into an image and then put it back into the document. I actually started working on that, and then right now it's abandonware, so that's a bit embarrassing. There's a reader for AsciiDoc coming up, which a lot of people apparently are using these days. It's also used by Git, the software, for all their documentation, so it would be important to support that. And floating tables is another feature that's missing from Pandoc, and that should be, yeah, one thing we tackle next. And yes, that's it. Thank you.
Great. Do we have any questions?
The table stuff I just mentioned.
How does this work? Sorry, I don't know how to. I have never used one of these before, so you need to please bear with me while I totally make a pig zero of it. On like so. Okay, there. Oh Jesus Christ! How can I not know how to do this? Okay, got it. All right, one, and this is around the back. Okay. All right. Hello everyone. My name is Chris Adams. I'll be talking about an NPM for environmental data. First of all, can I have a quick show of hands? Have I just confused everyone by using the word NPM in this talk? No? Okay, so we've got 1 or 2 people. All right. If you haven't heard of NPM, it's basically a way with JavaScript to kind of package together bits of code and libraries so you can have some kind of functionality to incorporate into another project or something like that. So I realized right after, as I was giving that talk, that maybe that's not immediately obvious to everyone. So, hello, my name is Chris, as I said. I'm not quite sure what I do, so I'm calling myself an environmentally focused tech generalist at the moment, because that tends to cover lots of stuff, all right? So I'm Mr. Chris Adams pretty much everywhere online, and I run a very, very small company called Product Science. It's a company in the UK, because I come from London, if you can't tell from my accent. So for the last 10 years, I've been doing a bit of development, so Ruby, Django, some front-end stuff, and I'm afraid I'm still using jQuery. That probably doesn't make me very cool, but it kind of works most of the time. Also, I've been working as a system administrator, as a UX person, a user researcher, and a product manager. So I've been working in lots of different fields, but I generally know enough to know when I need lots and lots of help, and that happens very, very quickly, which is why I now run a company and try and hire people to help me. So just a quick show of hands, has anyone heard of Bret Viktor here at all? Yes, one other person. Okay, Bret Viktor is one of my heroes. If you don't know who if you haven't heard of him, I'm so jealous because you get to find out who he is. He is an absolute genius. All right. This is Alan Kay. These are 2 people who are known for being good at computers and good at information. And this entire thing he says, like, I intend to invent a humane medium in which thinkers of the next century will see, understand, and create systems. Like, he really means that. Like, if you Google this person, or better yet, go to his website, worrydream.com, you'll see some absolutely fascinating videos. He is basically so far ahead of almost any kind of editor or design tool you can imagine. And he just shares all this stuff and writes these essays where he actually, I'll show you in a second, actually. He covers all this stuff, and he also basically has, he's aware that there's life outside of like Silicon Valley, basically. So this is like, he's been like talking about stuff like this for a little while here. Now, the thing about like 4.1 ppm atmospheric, this is basically stuff related to, if you want to disrupt something important, maybe you might want to try disrupting some of this stuff, or minimum viable planet is generally more exciting than, well, some other kind of web startups working in like the Valley, for example, or some things getting funding at the moment. And this is another like set of tweets where he's talking about this stuff. And it's very, very easy to kind of feel a bit daunted by what's happening with, well, everything around us and climate change and stuff like that. And he kind of did something to contribute to this. He started writing this essay, which he calls, well, basically this is it, what can a technologist do about climate change? And I've read this many, many times, and it's basically my new Bible, pretty much. Now, I've got to give you a warning, it's not a short read. It will take a long time to read through. And he basically sets out a plan like, these are the things you need to fix. You need to fix funding, you need to fix how energy is produced, how energy is moved, how you consume this stuff. But in particular, I'm interested in this one here, media for understanding situations. And I'll give you an example of like how this guy works and why he's so interesting. So he basically wrote an essay, but unlike other essays, the thing that he does which is really interesting, are we going to get where is it going to be? Haha, no, that's not it. Oh, bloody hell, it's got to be here somewhere, right? Oh, this is frustrating. Sorry, this is going to be so much slicker in my head. So if I double click on this, where do you reckon it is? Oh, it's got to be somewhere, right? Oh, here it is, sorry, it's on this part here. Let me just drag it across so you can see. Yeah, there we are. So he's got this cool thing that he does, where he writes essays telling you about stuff. Oh, hang on, this is the wrong one, isn't it? The thing I'm trying to tell you is this one here. Yes. So he'll give you an essay to tell you about what's going on. So you can write things, but he also kind of shows, well, I can tell you this stuff, but I can also show you the numbers, and I can allow you to kind of interact with this. So he's basically built an interactive essay. He says like, well, this is what we need to do if you want to get beneath to not release CO2, right? He's like, well, look, that's what we need to get to. And you see that all the stuff in the orange, that's bad. We shouldn't be there. We need to kind of we need to basically get that down to everything being blue. And that gives us an idea of just how big the challenge is that's facing us. So he uses stuff like this to kind of talk about how basically help people understand. But basically he uses this as a new form of kind of communicating with people. And he's got this really nice idea which he put forward called model-driven debate. And I'm going to show you a video of this one now because I've totally got this one now, I think. Oh, where is it? Oh, okay, let's go for it. Biggest debate. So here we are. This is the thing that he does and he's been speaking about recently. So again, he's talking about like why, so I'll just give some background. Model-driven debate, the general idea behind model-driven debate is that we're working with a medium with access to data. We don't need to just work with we don't need to imitate paper. So you could do something where you could have some prose, have something written here, but you could also say, well, you don't need to just take my word for it. You could actually explore some of the data with me. So what he does is he basically says, imagine this piece was written in the New York Times. Imagine if you could actually see the data and explore it yourself and try different scenarios. You'd be able to have like a much higher quality of public discourse. So this is him like showing these things. So maybe if you could see this, you could see the impact it's having in terms of reducing the amount of CO2 that's being emitted into the atmosphere, which is generally a good thing. We want less CO2 because 2 degrees of climate change is already enough. And he says like, well, okay, there's all this stuff here, but also look, you can see all my working. You can see how I arrive at my conclusion, so you don't have to just trust the things I'm saying. And like I find this absolutely fascinating. This is like magic to me. And it's really, really cool, but it's really, really hard to do something, to actually work with this, because this is like one example, but getting access to the data is often quite difficult, and we're here to talk about making data easier to access. So this is the thing he said, like getting data is one thing, but being able to kind of model data in a way that you can have some kind of informed discussion about this is even harder. So he says like these are the kind of questions you might want to ask, like how do you work out, say, okay, I'm going to pick on cows because I'll come back to it a bit later, but okay, what's your question for methane emissions for meat consumption? So if you have lots of cows tend to fart a lot. The methane they reduce is incredibly powerful. It's like 21 times as potent as CO2 for kind of creating climate change, right? And if you have less cows, and if you kind of switch to a vegetarian diet or something like that, then maybe you're going to what effect will that have on our careering towards this 2 degrees limit, right? And he says, well, that'd be really nice, but wouldn't it be cool if we could do something like take these models, if only these models existed somewhere, so I could write something and I could type in npm install, and incorporate something. So that really, really cool video where I can actually have some kind of model-driven debate and actually put forward an argument, and you can actually interrogate that and challenge my assumptions. It would be really cool if we could do something like that. And he says, well, basically the problem is models are really, really hard. Data is really, really hard. And at this point here, we could be like, oh, okay, I guess we're doomed, right? But I used to work for a company called AMI, and AMI stands for, well, as you can see, Avoid Mass Extinction Engine. That really was the name of the company. Now, they basically had a mission to kind of work out the carbon footprint of everything. And the idea was that there's this quote which is attributed to lots of people, but Peter Drucker is often used for it. So what gets measured gets managed. The idea is that if you want to reduce the emissions being emitted by, well, basically everyone, then it's useful to kind of know how much is actually being emitted in the first place. So we tried to work out the carbon footprint of everything so we could actually have some informed decisions about this stuff. So this was basically the plan. This isn't my company, I worked for the company, all right? And this is not entirely accurate, but it gives you a rough idea of what we were trying to do. So they raised a lot of money, like in more than like 10 million, about 12 million US dollars. And they spent the next 6 years hiring loads of scientists to basically read through all these policy papers, all these places where the data and the models actually were. And then they thought, well, okay, let's try and automate this. So they built models based on these papers. And they thought, well, let's put an API on this. So if you want to, let's say you're running a government or you're running a company and you want to reduce your emissions, or you want to see what decisions you can take to basically maybe switch from one kind of car to another or do something like this, then you can model that and you can see that. And there is ... profit, because not every single company that raises money ends up turning into some company making an IPO. So they spent 6 years trying to work out a business model, and we learned a lot of things along the way. I worked with them for a little while, and let's see what's next from here. And we built a cool thing. So the thing that we built was essentially like Google. It's like a search engine for finding all these models and all the information you might need to make a calculation. So if you forgive me, Google for environmental data is kind of what we had. So you could search for any kind of word. You could decide what kind of criteria you want to use. So if you want stuff only used by the IPCC, so IPCC, they're the people who make the reports, which are like hundreds of pages long, which decide what we're going to be doing. You can only use their data. If you want to use data from someone else, you can use that. So that's the kind of stuff that we were building. And the idea was that you could do a search like this, and then you could basically work out the footprint of something. So is this going to work? Let's see, this should be a 30-second example. So let's say I've searched for cattle, and I found a model to work out the impact of, well, basically reducing the amount of cows on Earth, for example. You can see, like, I'm basically working something out here, and then it's basically say, well, we've got this many cows. This many cows will produce this much CO2. That's what that much CO2 looks like, by the way. We're not quite sure. We kind of put it in there because it looked kind of cool, right? But I'm not sure if it really informed any decisions. But you can see that there's loads of stuff happening, like there's CH4 and CH2. So methane is the small one, and that's much more potent than CO2. So we translate it into something which is understandable to, well, normal people, basically. So we were doing something like this, and then there's other thing at the bottom where it says, look, you can automate these calculations. So we were basically trying to build a thing which you could have authoritative, audited, and automated calculations of this stuff, so that you could incorporate this into how your business or how any organization works. And we basically built that. And that was a big Java application, because it has to be big and enterprising, otherwise people aren't going to kind of trust it. And the thing we found out is that the platform was built in Java, but the best way to work with scientists was to run the models in JavaScript within the platform. And teaching scientists JavaScript is much faster than teaching developers to become scientists for years, because it takes quite a long time to become a PhD in astrophysics or environmental sciences or anything like that. So that seemed the fastest approach. And oh, JavaScript, right? That's kind of interesting. So we thought, well, wouldn't it be cool? What else could you do with that, right? So we kind of started, we thought, well, you know, the entire plan, right, was to do something about like the planet, right? So, you know, avoid mass extinction. So we thought, well, let's try to open some of this. So it kind of ruined the acronym, I'm afraid. Like open, Amy, you have to come up with something like OPEN, and we weren't smart enough or didn't spend enough time thinking about that part. But we made a thing called OpenAmy that releases an open source kind of project. And essentially all the data and all the data sets and all the methodologies we released. So this is all on GitHub, and it's under the MIT license, so it could be used in pretty much anything. That was the plan. So we got all the scientists, all the data they were writing in. They were writing in something called Creole, which is a bit like Markdown, but before Markdown, I guess, was more popular, I suppose. So we've got some of the science that's going into this stuff. We've got some of the data that you use to work out what kind of cow you might want to use, because different cows in different areas have different rates of methane emissions, I suppose, all right? And there's also the JavaScript to run this stuff. Now, some of these are really simple. So literally like amount of cows times like the methane per head, right? Some stuff like that. So basically you've got this stuff expressed as JavaScript. And this is like a simplification. There's more stuff, but this gives you a good idea. So we have science, we've got data, we've got JavaScript. Now, that could be packaged in something different, right? So there is this law that anything that's been built in JavaScript that can be written in JavaScript will eventually be turned into JavaScript. So we're thinking, well, what if you could run this outside the platform? And this is kind of my half-baked idea that I want to share with some of you and possibly talk about in the bar afterwards. So this is how I think it might work, right? If you can create some kind of context to kind of run JavaScript, you can read the CSVs because they're already on there. And if you can evaluate that JavaScript, then suddenly you've got a way to kind of embed this into anything. And yes, this person says npm install this. Kind of, is that too much of a leap? Sounds like it could work. If anyone has any opinions, I'd really love to hear from you because I think this would be a cool project. And yeah, that's it. Thank you very much. By the way, I run a meetup called cleanweb.berlin, and if you are a front-end engineer and you want to basically save the planet with your web performance optimization skills, we're talking about this book, which was released by O'Reilly, and we've got the author talking remotely because he lives in America, and him flying across to talk about saving the environment wouldn't work so well. But that's me, and yeah, you've already clapped, so I'll happily take any questions if there are any. If not?
Not yet.
Cool. In that case, we can all drink beer. Huzzah! Thank you.
All right, everybody. Thanks for coming.